Hello, in this video, we're going to have a look at a kind of like a rate of change problem in reverse. So in the differential calculus unit, we might be given a function to describe something, and then we're asked to work out the rate of change after 10 seconds, something like that, and you have to differentiate it, the function, and then, substitute the value in, blah, blah, blah. So in this instance, we're going to go in reverse. So what happens if you've been given a rate of change function and you need to work out, you know, an initial value or something like that. I'm just going to take it straight from the textbook just to keep it simple. Exercise 9p, there's not that many there, but let's have a look at question 4. Question 4 is water begins leaking from a tank holding 4,000 gallons of water. I don't know what that is in litres. The rate at which it is leaking, measured in gallons per minute, can be modelled by the function. So it's a rate that has been modelled. R of t equals minus 133 multiplied by 1 minus t is 60. So great, we've got a rate. Note that the rate is negative. So built into the rate function is the idea that it's leaking out water. Okay, so just be mindful of that it's already subtracting because of the rate. I say that because we're going to have, when we're looking at how much water is in the tank, then we're going to have to work out the capacity function, which I'm going to call big C of t for capacity. And it's going to have an initial value of 4,000 because that's what it is at the start. And then it's going to lose water over time. But I don't need to subtract anything. I just need to add on the integral of this rate. Okay, I need to add it on because the negative is already captured in the rate function. So this is what it looks like in practice. I might have to flick between screens a bit until I get there. So I have got it written down here actually just to make it a bit easier. So I'll start by writing down the rate function. So this is what, exercise 9p? Question 4. Oh, that's pretty neat writing, isn't it, Richard? Okay, fair enough. So question 4, the function is r of t equals negative 133 multiplied by 1 minus t over 60. Okay, great. So that means the capacity, so after 20 minutes, the capacity, which I'm going to use big C of t, is going to be 4,000, which is the starting volume, plus the integral from 0 to 20 of negative 133, 1 minus t over 60 with respect to t. Great. 0 to 20 because 0 is the initial, and then 20 is 20 minutes later, so we're assuming t is in minutes. Excuse me. So then we will move on, and I'm going to take out the constant value to make it a bit tidier. So now that I'm taking the constant out, it's going to be minus 133 multiplied the integral between 0 and 20 of 1 minus t over 60 with respect to t. So that's fine. And then the next bit is a calculator. Now, from this point on, you could technically work out what it is without a calculator. I mean, it's not that hard, really, but because of the fractions involved and stuff, it's probably more convenient if we do. So I'm going to flick to the screen now. Not this one, but this one. And let's put that calculation in. So it was 4,000 minus 133 multiplied by the integral between 0 and 20 of 1 minus t on 60, just using slash for divided by 60. Don't need to use the fraction button, you can just go 2 to t divided by 60, and then with respect to t, press return, and I get 1,783.33 gallons after 20 minutes. Or if you, excuse me, want to do it to 3 significant figures, it would be 1,780, 3 significant figures. We can confirm that, excuse me, by going to the answers, 9p. There we go, 1,780 gallons there. And that's all there is to it. Nice and simple.